The Masked Jerk Beats.
Today we're going to talk about slope fields.
A slope field is a graphical representation of the solutions of a differential equation.
Or a graph of the solutions of a derivative.
First, let's draw a slope field. So, our equation is 2x squared. First, we need to derive that. So, the derivative would be 4x. Now we're going to do that over here. So, let's start at 0, 0. We're using the point 0, 0. So the slope there would be 0 if you put that in the 4x. Let's do it at 1, 1. 4 times 1 is 4. So we draw a positive slope there. At negative 1, it would be negative 4. Now we're going to plug in all of the points.
Notice the pattern? As we move away from the 0, the slopes get steeper and steeper in either direction. We just plugged in each number for x. Now we have an equation that includes y because we derived implicitly. So the y and x both change the slope.
We can apply slope fields to everyday life. The slope changes on this hill as we change location. At the top, the slope is 0. As we move away from the top, the slope changes. We can graph the change in slope of the hill on a slope field.
The same thing happens on a slide. The slope changes from 0 at the top to steeper in the center and then 0 again at the bottom. We can graph this on a slope field too.
Slope fields can be used to approximate a function given a point on the function. For example, we know that at x equals 1, y equals 2. So if we go to 1, 2, we can do this. Remember that this is just an approximation.
We can also use slope fields to find asymptotes. For example, on this equation, since at all places where x equals 1, the slope is undefined, that means there's an asymptote there. Slope fields! That's all for today, folks.
Like a small boat on the ocean, sending big waves.
Today we're going to talk about slope fields.
A slope field is a graph. You're just staring.
Today we're going to talk about slope fields.
You gotta let me stop.
Yeah, you're good. Don't worry about it. Who cares?